light goes at 186,000 miles per second no matter what. So if you make the distance longer, it's going to take longer to get there. And that longer distance is still a second. You know what I mean? Because that's your time dilation. You know, it's just like if you turn down the information flow on a movie projector, right? You slowed it down, right? You slowed down the information that was put up onto the screen. It would look like that was slow and like it was time dilated, right? But everyone in the movie, they're just thinking slower, and you know, the bullets are going slower, the cars are going slower. You know what I mean? They don't know it, okay? And then what happens when I feed you the information even faster? Yeah, it starts getting faster and faster, and now it's up to normal. And then I turn it up, give you the information even further, right? And I turn that projector up so the movie goes really fast. Yeah, you give information. If you can disperse the information faster, time goes faster. If you slow down physics for everything, including your thoughts, and you can't process anything as fast, then time is going to slow down. It's like this is insane.
As a velocity vector in time. So what's the temporal velocity of the entire object? In Einstein's relativity, you have to remember that time and space are not independent of each other. Objects don't just have a velocity through space or through time, they have a velocity through space-time. We call this their forward velocity. To get at this, let's move away from our teapot for a second and talk about boats. Imagine two boats on an actual stream. One near the edge moves slow and one near the center moves fast. The slow boater reaches out an oar which the fast boater grabs. What happens? Instinct tells us that the fast boat is pulled towards the shore. We can think of the two objects as becoming one object, and the difference in velocities across its length causes a torque that rotates the overall velocity vector towards the shore. It's the same with the forward velocity of an object in a gravitational field. The gradient of velocities causes the overall forward velocity of the object to be rotated.
You are a liar, okay? That teapot has to touch the earth. You freaking dirty, woke liar, okay? I actually like this guy. I hate talking crap, but he's a woke piece of crap. He knows he's lying. He cannot be this stupid, okay? Equivalence principle. In the theory of general relativity, the equivalence principle is the equivalence of gravitational and inertial mass, and Albert Einstein's observation that the gravitational force as experienced locally while standing on a massive body, such as the Earth, is the same pseudo force experienced by an observer in a non-inertial accelerated frame of reference. But you notice how the equivalence principle says that you, while standing on a massive body such as Earth, it says it right. He won't say it because he's a lying piece of woke garbage, right? I actually like this guy. He's a cool guy. But he is woke. Yeah, look at that. It says right here, you have to be, the equivalence principle says you have to be standing on a massive body such as the Earth. You can't just be floating over top of it, okay?
Individual forward velocities start out being pointing purely in time, but the sum is rotated partially into space. And it's always rotated in the direction of the decreasing flow, which in a gravitational field is downwards. So, this is the motion of an object in a gravitational field. It gradually picks up velocity in the down direction. For an observer falling freely from the roof of a house, the gravitational field does not exist. It accelerates, and it pays for that acceleration by losing velocity, decelerating in the time direction. There's a certain way of interpreting the math of relativity that says that everything...
I thought falling objects aren't affected by gravitational fields.
We now know for an observer falling freely from the roof of a house, the gravitational field does not exist.
The gravity just curves space-time so that you make a geodesic. You're accelerating it down, and you just follow that geodesic, constant speed, straight line. But this guy's saying all this crap now? What What a woke piece of garbage.
Travels at the speed of light. Light travels at the speed of light through space, obviously enough. And we know that nothing with mass can reach that speed traveling through space. But if we interpret time as a dimension like space, then a stationary mass really is moving
See,
at
he's going into woke crap. If we consider... No. If we consider... That's like saying, if we consider the red universe, the red dimension, no. It's like if you shrink or contract a tall man, are you contracting or shrinking the tall, or are you shrinking and contracting the man? I say you're contracting the man, obviously. You're not contracting the tall. You know why? Because tall is an adjective. It's not a noun. A dimension is an adjective. It's describing direction. It's not. We arbitrarily pick our reference frames. Okay. We arbitrarily. I could say that I have a block here that this is whatever. This is length, the x, and going up is the y. Yeah, but you know what? Now length is this. Look, now it's width, now it's length, now it's width, now it's length. You know why? Because it's an adjective. That's why I could just flip it over like that and say, oh, this is length over here. Oh, no. This is width. We're going to change the width to length and width to length. You know why? Because they're adjectives. They're just descriptions. You can't visit. It's not a dimension like you can visit. It's a mathematical construct, for God's sakes. This man is insane.
Fastest possible speed in the temporal direction. This is something we can come back to another time. For now,
the temporal dimension he's talking about, he's saying about a higher dimension. A higher dimension. You can't. How is it orthogonal? Okay. The only reason we say that it's because we can take one of the spatial dimensions off and put the time dimension on. See? But if we have to take one of the spatial dimensions off, then what we put in the time dimension isn't really, it's just a mathematical construct, so we can do the math easy. Okay, it's not an actual dimension, you idiots. Otherwise, it would be orthogonal. You can't have any more. You can't say, oh, you can't see. It could be somewhere where you can't see. I could see 360 degrees around it. There's no other way to put another line orthogonal to all three spatial dimensions. Plus a dimension is an adjective, like pretty or big or red. Okay, it's not an actual thing. It's a description.
Let's go with it. The forward velocity of a massive object is pointed almost entirely in the time direction. On the other hand, light itself travels at the speed of light only through space and not at all through time. The photon's clock is frozen. You might imagine its forward velocity is entirely rotated out of the time direction into space, although technically photons and other massless particles don't.
Do you see how he literally thinks that time is a higher dimension, when all it is a result that when you move, it takes longer for all your information carriers to get from atom to atom, or synapses to synapses, or atom to atom in a clock hand, or whatever. All physics relies on this, and so all physics, including your thinking, slows down. How is that going into a fourth dimension? Huh? And he knows that you can't put the time dimension on to the XYZ axis without taking one of the dimensions off. That makes it a mathematical construct. Okay? You idiot.
Have a forward velocity, which is defined according to the ticking of their own clock, your proper time, which is 0 for the timeless photon. In this picture, a falling object trades some of its enormous velocity through time to pay for a small velocity through space. To us, the currency exchange looks favorable for space. A teapot gains a rapid plummet to its doom for an imperceptible slowing of its clock. We see the same favorable exchange when we try to convert mass into energy via Einstein's most famous equation, E equals mc squared.
So this teapot, he's saying that all this is happening because of the equivalence principle, but the equivalence principle he showed us that you have to be touching the planet. Then he tells us that when you're falling in a gravitational field, you don't feel nothing. Because you're just inertial, going constant velocity, straight line. But here he's saying, oh, that is, well, yeah, but you're time dilated. How are you time dilated? Like, he's so contradictory, it's sickening.
Squared, the speed of light is the exchange rate, and the speed of light is very large. By the way, two of my favourite physics channels have great, slightly different explanations of this effect. Check out Nick Lucid on Science Asylum and Eugene...
Yeah, his is crap, and so is this one's even worse. They're all... Jesus Christ, these two are worse than this guy. Jesus.
Troyansky's channel to get their takes. So, is that it? Do we now perfectly understand the source of gravity? Well, speak for yourself. I'm still quite confused. This raises thorny questions like, what about a particle with no size, supposedly point-like particles like electrons, quarks, etc.? Well, actually, nothing truly occupies only a single perfectly defined position in space. Quantum uncertainty means that everything is always in multiple places at once, and so experiences a gradient in time flow. But actually, general relativity doesn't need quantum mechanics to explain gravity. It's enough to imagine clocks that are infinitesimally separated, and we still have our time gradient. The other thorny question is about light itself. If photons are already fully rotated into the spatial direction, how is it that they're also affected by gravitational fields? They have no velocity through time to trade.
They're not affected by gravitational fields. They just move in a constant velocity in a straight line. It's just gravity affects space-time. Accelerates it down. That geodesic is the acceleration of space-time going to down, okay? And whatever's in it, the photon or you falling, you know, if you're falling, you just stay with the same spatial coordinates the entire time you're falling, because space-time is falling with you. So relative to you, you have no time dilation. You're inertial because you're not moving. You're just floating there relative to space-time, okay? This man is insane.
But light does bend in a gravitational field. Astronomers see it happening.
No. Gravity pulls down space-time, right? You know the geodesic, right? It accelerates down, and the light just follows that path, okay? It's a straight path. It just looks curved because it's in space. It's in curved space. The straight lines in curved space are curved.
All the time in the effect we call gravitational lensing. In fact, the imaginary paths of light rays were one of the most important tools that helped Einstein develop both special...
Yeah, because gravity, right? It bends and curves space-time. It accelerates it down, right? Yeah. It doesn't do anything to the light. The light just keeps going 186,000 miles per second. And as the space-time goes down on its geodesic, it just follows that geodesic. It's just staying inertial because it's staying with the space-time. The space-time is actually the one that is curved. It's the one that's falling. It's the one that's accelerating.
And general relativity. So we had better understand the effect of gravity on the path of light. To do so, we're going to need to shift our perspective in a couple of mind-bending ways to see how the flow of time determines the paths of even timeless particles.
So, falling in a gravitational field doesn't have any effects. Now he's saying light has effects. You got time dilation, all this stuff. What the?
And with those new perspectives, we'll gain a new insight into the source of gravity that seems weirdly at odds with everything I just told you, and yet is simultaneously...
It seems at odds and everything. Yeah, it does seem at odds when you lie like a woke piece of crap.
The gravitational field does not exist. The gravitational field does not exist. We now know this as the equivalence principle. It states that there's no experiment that you can do to distinguish a frame of reference in freefall within a gravitational field from a frame of reference floating off in space in the absence of gravity. Provided
and guess what? There's no time dilation out in the outer space, so there's no time dilation in free fall, right? Because they're both inertial, and you don't have time dilation in free fall.
For an observer falling freely from the roof of a house, the gravitational field does not exist. The following. For an observer falling freely from the roof of a house, the gravitational field does not exist. The gravitational field does not exist.